you, Kenneth. Thanks, everybody, for having me. It is a lot colder than I expected. I don't know how you're sitting there with a T-shirt, because I'm shaking from being cold over here. You're not from Texas, are you? No. Okay, so it's really good being here. This is really something that is close to me. Teleport is one of those products that I discovered at a KubeCon several years ago, even before I was at Vonage. So seeing it really grow at Vonage with our new platform is really, really fun. But before I start, I really wanted to talk about something I saw the other day. I was watching Netflix, and I was watching something about how the GPS satellites are managed, right? If we want to talk about scale, there's about 26, 28 GPS satellites managed by the military, serving 6 billion customers with a B. So my problem doesn't look that bad anymore, right? But yeah, there's, how many people you think manage that day to day? Any number, throw out a number.
Probably 2.
How many? 2? You're close. 10. 10 people control how you get an Uber from the airport to here. Literally, 6 billion people, all of us every day use GPS. And because of process and automation, I'm sure through the years, they've got it down, but there's 10 people in the Space Force under the GPS unit that are managing these satellites. So I thought that was pretty cool, and I thought, you know, if they can do it, so can we, right? Okay, so I'm gonna talk a little bit about how we're using it across our 100 and change clusters. We want to expand to a couple of thousand more here before the end of 2025. So my name is Eddie Wasif. I'm the Chief Architect of Vonage. Many of you have not heard of Vonage, but I'll talk about Vonage here in a little bit. But we were recently acquired by Ericsson, so we are a wholly owned Ericsson subsidiary. My job, I was hired from a company called Solera, but my job is to do what I did there, which is to modernize and evolve the platform into, from a holding company with 10 different technology stacks into an operating company where we can expand this, evolve it, and continuously deploy things very quickly and make it more developer friendly. So I have a team of architects, but my architects aren't traditional architects. Talked a little bit about blurring the line there, but they're developers, they're DevOps, they're architects. So what they do is they define architectural guidelines. They use development and DevOps practices to help enforce it. And so one of the things that we put together, over here? I always do that, by the way. If you watch any of my talks, I'm always like, there, not there, not. I'll stay right here, thank you. So as I say, yeah, so we enforce architecture by building tools and leveraging vendors, making it easy to integrate, and that's where we've used Teleport. So here's some of my contact information. Please add me. Go check out some of the weird code that I write. Read a couple of blogs, snap, tweet, thumbs up, whatever you'd like. So what about Vonage? Many of you probably only know Vonage from voice over IP, right? And that is where Vonage started 20-some years ago. But throughout, and I actually have a really nice shirt, but I'm freezing, so I'm wearing 2 jackets over it. We do a lot more. Throughout the years, we've become a leader in unified communication, which is like your Zoom, right? So we have products like that. Contact centers. We also have conversational commerce, where you can go and actually through a chatbot or through IVR buy a product. And we also have a wide suite of APIs for communication. We're headquartered in New Jersey. We have offices all over the country, all over the world. And we serve 100,000 businesses worldwide. Some big businesses here that y'all use every day. You get a notification that I'll stay here. That the driver's at the door, that probably came through us. Your latte is ready, that came through us. We are pretty much competing with the big boys like Twilio, Zoom, and so on in the different areas. We have a very vast developer ecosystem. We have over 1 million registered developers for APIs. And you can sign up, you can become a developer and start communicating with people. So the thing that we have to deal with is we need to be everywhere you are. right? Video needs to have low latency, so we need to deploy in 19 different parts of the world. And we need to respect the geo boundaries. We need to respect the latency. We need to be able to deploy, roll out quickly. We need to be able to secure it. We need to make sure that somebody doesn't accidentally open something up or copy something from one region to another and get us in trouble. So what we're building, what we've been building for the last several years, is something we call the Vonage Communication Platform, or VCP. So it's important, the wording here, and I always make sure to highlight it. We've acquired a lot of companies with different stacks. We are not telling them, these companies and these stacks were very successful, right? That's why they were acquired, right? You can't just cut them off and move it. So we're evolving. It's the next evolutionary step in the architecture. How do you meld and take the good things from 10, 12 different companies and make it the standard moving forward? We also need to be cloud agnostic. Because when you pick a company, you're not going to say, I only want to acquire a company in AWS, or only want to acquire a company in GCP. Well, if you're building something for one cloud or the other, these guys are left out. So it's cloud agnostic. We're very much in the standards-based system. Things like the Apache Foundation, the Cloud Native Computing Foundation, these are folks that spend millions of hours figuring out where the problems are, so we don't have to, right? Things change, things evolve, and going with a standard, it's a good bet that you're on the right track. What else? Security and reliability, that's why we're all here, right? If we're going to build a standard for, in the last slide, I think I didn't mention it, but in Vonage, we have about 800 developers. In Ericsson, there's another 20,000 more, right? So that's a pretty big group of developers we're trying to enable them to build things quickly, get it out quickly, but we need to make sure it's secure. You can't PR 20,000 developers code. That's, you're gonna lose your mind. And so we have to have another process to do it. And so being secure, having the tools to also comply with any regulatory or compliance issues, whether that's GDPR, CCPA, PCI, HIPAA, those are the things that we need to be able to do programmatically and very easily as well. The other thing we wanted to make sure we did, and we talked a little bit about this, is we want it to be easy and fast to learn and integrate. Traditionally, architects might write a document, give it to you 6 months later, wait 2 years for you to implement it. By then, there's a new programming language and 5 JavaScript frameworks, right? And so we're already behind. So it needs to be fast, it needs to be easy to implement. And like we were saying before, you know, there's a nice philosophy that says try to be like water. If something difficult in your life, like, you know, stops you in your tracks, don't try to push it. Like if there's a water stream and you put a rock in front of it, it'll push a little bit, but what will water do? Water's gonna find a way around it, right? It'll go through the cracks, it'll go underneath it. And developers are great at that, right? I was a developer for 15 years. If there's one thing that caused me to wait an hour, I was gonna find a workaround. And we didn't want that. So you gotta make sure that whatever you build is gonna be a delight for your developers to use. And then finally, it needs to be cost effective, right? Because if it's gonna cost you more than what you have today, in the macroeconomic situation we're in, it's not gonna get anywhere. So, sounds like a short list of really difficult things that are very hard to implement, right? And they are. And I'm not gonna say that we're a bunch of magical developers that were able to sprinkle some dust and make it happen, but we're moving in that right direction. And what we've done is we've built 2 major pillars for our communication platform, our fabric and our core. Our fabric is what's interwoven through all of our systems and our infrastructure, right? Everything that runs in the Vonage communication platform is in the fabric, and that we use that to vend infrastructure. You want a cluster, you ask the fabric, it gives you a cluster. You want a service, you ask the fabric, it gives you a service that can be deployed on that infrastructure. And it's gonna give you the scalability, the monitoring, and the observability through that fabric. The core part are tools and services that everything uses. Identity, log management, alerting, scalability, deployment. These are things that are built on the fabric but are used by different systems. So those are the kind of the two parts of the VCP, the Vonage Communication Platform that we have. We're going to focus on the fabric, because as you can guess, Teleport plays a key role in that fabric. And before we talk about exactly how, let's talk about the pillars or the requirements that we have for the fabric. It needs to have zero trust, right? You can't ask somebody to go in and SSH to a server or to exec into a pod and to do something and get it deployed, right? And with that many developers, you can't trust anybody to promise that they're not going to do it either. We also need to make sure it's globally accessible. Because if you're having a video conference with somebody in Australia, you don't want to have that to go all the way over to North America and then back to Australia. It's going to be a horrible experience. We need the auditability and the programmability. And these are great things that we used to say a long time ago, but in the last 4 years, we've seen two major occurrences happen in the world that make this top of mind. When COVID happened, overnight, everything had to change from in the office to being at home. You couldn't rely on the network boundary. You couldn't rely on VPN necessarily or a laptop. You had to shift everything to start working remote. Earlier this year, we had embargoes, where if you had infrastructure or systems in certain parts of the world, you had to get them out, and you had a timeline. Also, you had to be able to quickly block any access from those parts of the world. So having the programmability, extensibility, and the audits were key. How do you prove you're blocking IP ranges from that part of the world? That's very important. And having it across the board is paramount. You can't say, well, I moved the video stack out of Russia, out of one place, and then somewhere else, right? And I left the SMS. You can't do that. Everything has to be at the same standard. And so with that, we went out and started designing our VCP fabric with a distributed hub and spoke model, a unified control plane, if you would. Very similar to how Teleport is designed, and that's why we kind of worked really well together. So the way it's designed is we have what we call seeds. A hub and spoke, you've got a centralized management system and things around it that communicate back and forth with it. So we have 6 of these seeds around the world for redundancy and for distributed access. They manage dozens of clusters each. So we have hundreds of Kubernetes clusters managed by these 6 seeds. We also employ DevOps practices, so we have about a dozen applications and tools that get stamped onto every cluster. Teleport is one of them. Let's say your Grafana or your MLA stack, monitoring, logging, and observability. We add things like security scanning tools. We add other things as well. So these are all the things that get put onto the cluster and are now secured by Teleport. But if you're going to do that and you have 10,000 applications deployed, how are you going to limit that across the board? So we use our corporate group membership to propagate labels, that we have Kubernetes operators that intercept the deployment, add those labels, and now when I log in, I only see my product's applications or my product's clusters. And we can go a step further where you can say, Eddie is not allowed to see or is not allowed to exec into any pods that are in Europe because of GDPR. And we can do that programmatically by adding the labels of the cluster, of the cloud, of the region, and tying that to the group membership. But what if we have to break glass? We built in the escalation process into Teleport that allows automated integration with Jira and our Slack, so that very quickly, if there's a problem, somebody can request it. It'll go through our escalation process. If a certain amount of time doesn't happen, it gets auto-approved, and we record everything they do. So that right there makes the developer's life very easy. Rather than waiting a few days or trying to find somebody in the middle of the night, when things go bump, they escalate, they get access, they fix the problem. Everything we have is driven through GitOps, so even if they were malicious and they deleted something, guess what? That reconcile loop is going to bring it back. It's pretty frustrating. I've tried it myself to fix something, and it keeps coming back. But So these are kind of the things that we put in place to get to those 6 pillars that I mentioned earlier. And so let's dive a little bit into how Teleport has enabled all of that, right? How we're able to go from those 6 regions to the hundreds of clusters, to the thousands of apps, and control it all through our group membership. And what we've done is we've built a couple of Kubernetes operators to automate that for you, right? There's been some really cool things on the roadmap that are coming in place, but the version we have doesn't have that, so we had to augment it. But what this will do, like I mentioned a little bit earlier, it'll intercept that call. It'll add metadata to that deployment. So if you think about the workflow, you're a developer, you want a cluster, you submit a pull request that says, this is me, I'm looking for this cluster in this cloud, in this region of this size. The vending machine kicks up, it goes and provisions, makes those cluster API calls, the cluster gets created, the operator intercepts it and says, let me add all the user metadata to that. It'll now create it, add the Teleport licensing, add all the additional information to set it up, point it to the right seed, which is a leaf node in Teleport verbiage. And now when they log in, they sit there on the portal hitting F5, boom, the cluster shows up and it's scoped just to them. You can go a little bit further and say, I'm gonna create this, but I only want it to be QA. So now the devs can't see it, but QA can see it. And so the operator does it a lot through the dynamic labels. We've also tackled VPN, which I dislike with a passion. And we used to have these internal apps, these admin portals that were all over VPN. We actually took the Teleport application structure and created a CRD. And a CRD is a resource that Kubernetes understands. So in the same manifest that they have, they can just say, I want to expose this to either a subset of my group or the entire population of Vonage. Our operator picks that up, calls the Teleport API, and now they see their application secured in their Teleport portal over the internet. So that's how you win. That's how you win over the developers, by making it a lot easier for them. What else? And finally, escalations. Like I mentioned, we have the escalation policy integrated into our Jira and to our Slack, so you can approve from one or the other. But we also added a mechanism also through a Kubernetes operator that says if this is taken over an amount of time and it's a Sev1 or Sev2 based on the request, it'll auto-approve. The system has approved your access with a shorter amount of time and will record all your activity that you're doing in there. So really, Teleport for us aligned with our values and our design. It followed a lot of the same things, and maybe we learned a lot of the things from them on how to deploy and secure at scale. So using that hub and spoke model through a distributed model, using the labels to secure all your artifacts, and using a little bit of scripting, or in our case, operators to augment that, really allowed us to scale this out in mass to thousands of applications across hundreds of clusters. And I'm close to time, I think. 10 minutes. Oh, I thought you were telling me I was done. My bad. Well, with that though, I'm sure, I hope you guys have a lot of questions for me. Let's take some questions.
Thank you so much also.
Thank you. No.
Yeah, anyone have any questions right here from Mr. J?
I feel like I'm the questions guy. Just very simple. Your Kubernetes operator, will you be willing to share that or open source it for the rest of the community?
We are looking to open source. So the question is, are we willing to open source some of our stuff? The short answer is yes. We are looking to open source quite a few of our products. The longer answer is we need to go through the necessary steps with legal and all of that to get that out there. But you should be seeing some stuff very soon from Vonage in the open source world. No problem.
Over here.
You tell us a bit more about the OIDC claims injection stuff that you're doing in order to.
So the question is around the OIDC claims injection when we log in from our corporate identity provider, and how do we translate that into Teleport. And so through the mapping, what we do when you log in is we have certain roles or groups in our SAML that we map directly to well-known labels. A lot of those labels are coming from ultimately the cloud provider and the group name. So what we do, what our operator does, it says, I'm going to look and see what your cloud account ID is, what teams are tied to that, and inject those claims, which are then correlated to labels. I'll give you an example. I'm part of product A, and I'm part of the architects group in product A. That'll be two groups in there. We can now add those as labels into the teleport claim, and any piece of infrastructure that our fabric creates is tagging and looking for those labels. So it'll say product : product A, level : dev, level : QA, level : architect. Developers can request a limited set of that, so they can say it only has to be QA or only architecture, and that's how we restrict the access to that. We then create teleport policies where you can request escalation. Another one I didn't mention is the geo. So by default, let's say North American SREs can't access EU for certain compliance reasons, but they can request, I want EU access to QA. And that would go through audited, and then whatever they do would be logged in. So that's kind of how we do it.
Any more questions?
We've got a whole 10 minutes apparently, so let's.
Question over here. Sorry about my squeaky shoes also.
So this is really interesting, and I think a lot of the other engineers in the room kind of implicitly understand why this is so valuable. But let's say there's a pointy head who you need to justify this to. How would you encapsulate the value to the business for everything that you described here?
Yeah, so that's always a tough question, right? Is how do you get the business to understand the value of securing and then automating your security so that it's dynamically created and dynamically provisioned for everyone. So some of the things that we did initially is we looked at potential JIRA tickets to get access to some account, escalations for EKS clusters, finding an SRE in the middle of the night when something goes down. And we looked at that across the board and we measured, kind of did that, right? And that's a little bit of how we initially justified it, but that's not the best way to do it. What we ended up doing is we utilized some other tools to measure DORA metrics. And some of the most important ones that we look at, mean time to recovery and mean time between failures. And we correlated, in a lot of cases, mean time between failures were more frequent because somebody did something manually and they forgot, right? And so once you have that, if somebody goes into a QA, tweaks a little something here or there, and then when you go do a production, it doesn't work, that causes an outage. And that became more frequent with our mean time between failures. Mean time to recovery is another one. I mean, it's composite because a lot of it is around the automation, but being able to quickly identify where something is going bump and getting the right people to get access to that to figure out if we need to roll back or if we need to fix something or tweak something was paramount. And a lot of that time was waiting on tickets to be resolved, which is why we added the automation. So those two were very significant. When, like I said, evolutionary, so we don't have automated rollbacks. A lot of times somebody had to go look, right? And if you're waiting for that person to wake up and the ops genie to answer his page to go do it, it costs a lot of money, costs a lot of time. So our customer sat scores were very low. As we started adding more and more of these features, you started seeing creep up. Even if there's an outage, and I'll tell you this from experience, if you have a problem with a customer has a problem on your platform, having the quick turnaround and the conversation, candid conversation with that customer will make that customer stick. Even if it's a bad problem, they see that you're working on it, they see that you're doing the best you can, they understand we're all human, right? And they'll stick with you versus ignoring them. We're saying, well, waiting on this developer to get back from vacation because he's the only one with the SSH keys, right? Or my laptop won't load, or some weird reason like that. And so that's That's how we ended up justifying a lot of the efforts and costs that we're putting into it. It's not a science, right? Every company is different, and you really have to look creatively at where some of these problems are coming from and trying to put a time around that, right? No two companies are the same. And looking at it candidly and looking at it creatively, you'll find the justification.
Thank you.
Thank you.
Any more? Okay, over here. Perfect.
So I had a question around break glass. You mentioned break glass within teleport. What's your break glass when teleport goes down?
That's right. That'll never happen. So that is a great question. And now I'm warmed up a little bit. You can see all my ad stuff. I've got the matching socks too for Vonage, right? Hello? Okay. So very good question. We actually thought about that, and we use a product to vend our Kubernetes clusters. We don't do it ourselves. And that product has a break glass situation where we can get to the clusters if we need to. But another thing that we've done, and this is a little bit outside of teleport and all that, but we set a high standard for availability, and we ask the teams and the devs, build it in a way that it auto-recovers itself, right? You'll be surprised how many things in Kubernetes will be fixed when you just kill the pod. And so we use things like kubehealthy or custom operators to run tests. If something fails, we actually have a teleport check that says, oh, the agent can't talk to the seed, to the leaf node. Go regenerate that through TCL. Is it TCL? TSH. And then delete the pod and have it restart. Fixes itself 97% of the time. 3% of the time is an escalation, but that's much better than the rest, than everything going down. So a little bit how we do it. Thank you.
Any more for Eddie up here? No. All right. Well, thank you so much, Eddie. This is great.
Thank you so much.